Okay, we're in chapter 2, and we'll just look at what they did in the text with, they looked at the limit as z goes to I think. Oh, I lost it here. Oh, yeah. Z goes to I of z squared is -1. Okay, so again, the idea is um, we need to be able to, given epsilon greater than 0, we need to find or produce delta greater than 0 so that z minus I less than delta implies that z squared minus -1 is less than epsilon. Okay, so again, the game is somebody would give me the epsilon, and then I would need to tell you how to find delta. And typically, delta is a function of epsilon because, well, it seems like it ought to be if you have to tell me epsilon first before I can produce delta, then, it has something usually to do with epsilon. Now, similar to the case of 2z, a lot of these do just start with this left-hand side of that epsilon inequality. So I have z squared, and I can write this as +1 or leave it as the -1 if I want. Now that factors, this is z plus I times z minus I. And so I'm going to actually write that one first. So this is the absolute value of z minus I times the absolute value of z plus I. Now the key here is, again, notice that, I need z minus I to talk about delta. And so, I'm going to make sure that I make z minus I less than delta. But then I still have this z plus I. And just because z minus I is less than delta, it doesn't necessarily tell me a whole lot about z plus I. And because, I don't know what delta is. And so often when you run into these cases, this particular piece of algebra here, that we've got the nice delta that we want, but we've got that other term there. Generally, what you do is you kind of come over here to the side and you say, well, okay, so here's what we'll do. We'll assume delta is never bigger than, and we pick a number. It's got to be a real number and so forth, but it's never bigger than. And often the number 1 works out very nicely. But it doesn't have to be 1. It could be 2. It could be 1/2. It could be anything. We're just going to assume that delta is never bigger than some number. Okay, and if we go with 1, it tends to be a little simpler. Now, why would we do that? Well, the reason is if we know that, so never bigger than 1, so I know that no matter what the person chooses for epsilon, they could choose a huge number like 1,000,000,000. Well, what I'm going to do is I'm going to assume that z is at least within 1 of I. Now, let's look at a picture of what that means. Okay, here is I. And so let me put 2I up here. So if z minus I is less than 1, I am in this circle right here. Okay, so that's what that means. So my z, no matter what, I'm going to say z has to be in here. Okay, z is somewhere in there. So now, I'll come over here to the left. What does that mean about z plus I? Well, if I add, so up here I had z plus I. If I add I to any z in this circle, what it does, it just shifts it up by 1. Okay, because I is the y value. And so I'll draw this a little bit smaller. There's I, there's 2I, 3I. And what happens is z plus I is in there somewhere. Well, now what I know that means is, and you might have to kind of check that to convince yourself, but what I know then is that this number, the absolute value of z plus I, well, it's no bigger than that 3 there. So if I come out here, that distance is not as big as 3. Okay, so I know this is less than 3 if I make sure z minus I is less than 1. And so what I can do is then say that this, coming back to here, is less than 3 times delta. Okay. At this point, assuming, and again, this is assuming z minus I is less than 1. Excuse me. Okay. Now, but I need this to be less than epsilon, no matter what is chosen for epsilon. And so I need then that delta better also be less than epsilon over 3. So I divided through by the 3, just like I had, oh, I don't have it here, like I had done with the 2z case. Okay, so if epsilon is smaller than 3, then delta being less than epsilon over 3 will mean that z minus I is less than 1, right? Because that'd be 3. 3 over 3 is 1. And so to get to here, I had to assume that I was less than 1. But it may be that I have to get smaller than that yet, depending on how small epsilon is. And so what I end up saying then is that I pick the minimum of the epsilon over 3 or 1. Okay, so again, just to get to here, I just made an assumption that, hey, I'm just going to always choose delta to be 1. So z minus I is less than 1 or less than delta. That got me somewhere on my algebra, but then I had to also take into account, well, yeah, this thing back here, right, what I started with needs to be less than epsilon. That has to be less than epsilon. Well, I've got it less than the 3 delta, and so I have that 3 delta better be less than epsilon, so I divide both sides by 3, and I get that. Well, depending on what epsilon is, this number may be bigger or smaller than 1. If it's smaller than 1, then delta has to be smaller than 1. That's okay. I assumed it was no bigger than 1 to get my 3 delta to begin with, but it could be smaller than 1 as well, and in which case I'll use epsilon over 3. Okay, so that, I won that game by, given an epsilon greater than 0, I will choose delta equal the minimum of epsilon over 3 or 1, whichever one's smaller, and I will win. Okay, I'll win that game. And again, we could kind of check. I haven't tried checking. So let's see. Suppose we we pick epsilon to be a half. Then according to this, we would need to choose delta to equal epsilon over 3 or a sixth. Okay, because that's the minimum of a sixth and 1. And so, will this work? Well, if I choose that, so what I have right now is delta minus I has to be less than a sixth. Okay. But what I know then is if this is true, that implies that delta plus I is less than 3. The absolute value of delta plus I. Now, actually, it's even smaller than that. But all I really needed was, because delta is smaller than 1, I know that delta plus I, that absolute value, is smaller than 3. And so I know then that if I multiply through by 3, I get that 3, well, actually, I need to do it in the right order here. So now I will multiply by my absolute, well, let me actually unfactor. So, whoops. Oh, and I'm sorry. Look at that. I apologize. I said delta, I meant z. um, and z here. Gosh, let me see if I screwed that up really badly. No, I got z's and all that. All of a sudden, for some reason, I switched to delta. Sorry. Um, my delta is the min, so I look at z minus I. It's less than 1/6. So I'll repeat that stuff. Z minus I is less than 1/6. Now, since delta is equal to 1/6, I know that z plus I is less than 3. And again, that came from that whole one business and so forth. So if I take my z squared minus a -1 or z squared plus 1, then I know that that is equal to my z plus I, z minus I, like that in absolute values. But now, because of this over here, I know that this is less than 3 times 1/6 because of the 1/6 there. And that is less than the 1/2, which is what what somebody gave me, epsilon of 1/2. And if it was 1/4, then, same sort of thing. I would use delta equal 1/12 if epsilon was 1/4. And, this would all still work. So that's the game. And it can be definitely tricky, playing this game and working with the algebra. But again, typically, if you can simply do some sort of factoring, right? So if I start with some f of z minus w0, and if I can somehow factor that into, my z minus z0, and then times, something else, another factor, a factor here. So if I can do that, then, typically what I would do is then say, well, let's assume z minus z0 is, and I'm going to use 1 again, it might not be 1. You might decide some other number that would work better. But I'm going to assume that's less than 1, which hopefully means that that factor is less than some number k. Okay, that's typically what I try to do. And so then what happens is we get less than k times z minus z0, and then that's equal to k, well, actually less than k times delta. And so then if we make that less than epsilon, we choose delta less than epsilon over that k, and so we end up choosing delta to be the minimum of that epsilon over k and 1. And again, it might not be 1. For whatever reason, it may make sense to use a different number. But if I can do the factoring like that, that's typically what I try for. So really any power, this would work just fine for, because if I have z to the n minus whatever that w0 is, then I can typically factor that um, in that W0, well, whatever it is, it would be Z0 to the fifth, I'm sure, right? So this would be Z to the fifth minus, Z0 to the fifth. And I'm going to be able to factor this into Z minus Z0. That's the part I need. And then this other factor. Okay, and that other factor, what in this case I think is Z to the fourth, and then plus, oh, what do we have? I think we have, would it be 4? Yeah, I think 4 Z cubed Z 0, like that, plus and so forth. But it would factor, and then again I would try to get a bound on that based on saying this had to be at least no bigger than 1, and I would go from there. So it's that algebraic game. If you do it enough times, you kind of get used to it. And that's just one strategy for these. Okay, there are definitely lots and lots of strategies for different types of limits, but we looked at one, and again, we're not, I'm not trying to push this real hard, but I do want you to get exposed to this epsilon delta definition and kind of the general, some general strategy. Okay, there's the general strategy for trying to solve some of these. Okay, so there we go. There's Z squared.